So my name is Bruce Carpenter. I'm the name that you see if you went to the course catalog and said, who is it that's attached to this course? That would be me. However, what that course catalog doesn't tell you is that I'm not actually the instructor proper for these courses. I am the associate director of the NetMath program. So I actually oversee the instruction for about 13 different courses. So every course that you sign up for has an associated TA with it. And so the TA is going to be one of your primary contacts to get help through the course. However, if you ever have a problem and it's not resolved by the TA or by one of the graders that we have for your course, that's when you would email me and I will walk in with my big stick and make things go away. Okay? So the purpose of this orientation session, I want to sort of go through and explain the format of the course, just to give you a certain level of familiarity and give you a sort of leg up on how to get started. I want to talk about some of the course policies and make sure that everybody has an opportunity to understand them before you run into a policy that you didn't necessarily know about. So when you log into Mathable, if you've already created your Mathable account, when you log in, you should see, if you've actually followed that URL and paid the course fee, you should see a course, and I'm just going to pick one for purposes of discussion. So this is what you see when you log in, and of course, if you're in a different course, you'll see something very similar to this. On the left, you'll see a series of lessons that constitutes the actual syllabus for your course. This is where all the electronic textbook is located and also where your homework problems come from. On the right, you'll see the welcome page. And the welcome page has a lot of information in it that I want to make sure that you understand what's there in case you need to refer back to it at some point during the course. So the very first one is welcome and getting started. So after you get through the welcome to your summer session course, there are a couple things I want to point out, one of which is every course has a teaching assistant who has a name, but who you actually email with that link. And if you click on that, it actually opens up an email that you can fill in and ask your question. Please make sure that you're using either Firefox or Chrome. The system that we're using, Mathable, is somewhat compatible, and you could probably get by if you use something other than Firefox or Chrome, but why make life hard on yourself? Use one of those. There's also an introduction to Mathable and a student guide. The student guide is a list of policies for your course. You notice that both of them are available at the same link. It's basically the same link. So the student guide, I'll just bring it up really quick. This is some information about how you're going to be assessed, right? Mathable assignment grading. I'll let you read through that. I just want to make sure that everybody knows that the way the course runs, there's already information available and you can go off and find out about it. Every course has a Piazza form. I'll say more about that in a little bit. There are also the grading policies. That's all of this is available on the welcome page as well. If for some reason you would like to have an accommodation for disability, please let us know. We will work with the appropriate office on campus, or if you are on a remote location, because you don't have to be on campus to take this course, we will work with your local proctor. And there are some other things about how to prepare for exams. And of course, if you're taking an off-campus exam, that's a link so that you can understand what the policies are around setting up your proctor. So the other thing is an intro to Mathable. I'm not going to go through this in great detail, but I'd like to point out that this is meant to be a very quick overview of how to get started in the system, et cetera. And so it's relatively short. I encourage you to look through it. Pardon me. So off on the left, you'll see this lesson 0, getting started. That's the place where it's really useful for you to get started. And so the very first thing is called an intro Mathable. That is a quick overview of the system. And there are a couple comments that I'm going to make about that in a second. There's a how do I, which is some of the usual things that you're going to need to be able to do in the system is collected together inside the how do I. It's meant to be a very quick reference guide for you. A scratch pad, this is a place where you can keep code snippets or write yourself notes or et cetera, et cetera. It's a convenient place to locate that. And then there's a try it. Your homework comes from the try its. These are the electronic homeworks that you'll be working on and handing in and getting feedback on, et cetera. So to finish our tour through the welcome page. Getting help in this course, the primary method to do that is via the Piazza forum. Everybody used Piazza before? Or if you haven't, it's actually not that hard to pick up. There is an access code. So you put in the access code and suddenly you're in the Piazza forum for the class where you can ask lots of questions. I sent out course start instructions for various courses at different times as they became available. There's already a lot of activity on some of the Piazza forums, right? So people are already beginning to use that as a resource. Convenient bookmark for Piazza. There is a couple resources that I'm going to give you for if you want more in-depth documentation about Mathematica. Because this system actually has a built-in web-based interface to Mathematica. Anybody heard of Mathematica? Used it? Do you know where Mathematica was developed? Right here. Wolfram Research is a separate company, but Mathematica itself was conceived and first originally created here at the University of Illinois. So we've been teaching using Mathematica in the format that you're about to engage in for 27 years. 27 years I've been doing this. Now, the only reason why I point that out, other than like I must be really, really old, this is not a relatively new phenomenon. This is not some wild, radical experiment. This has been going on for 27 years. So I'd like to point out, as we go along, some things to think about. We have a long track record of successfully teaching students, but there are a couple things that you guys need to bring to the table to ensure that you have the greatest chance for success. So, for example, the Mathematica documentation, I'll just quickly go there. This is Wolfram Research's own website that explains all the documentation. Mathematica is a system that is called a computer algebra system, but it's actually much, much more than that. It's a programming language. It's got 6,000 built-in commands, and you can balloon that up to many tens of thousands by loading in packages, et cetera. That's a lot of commands. The number that you're going to need to become familiar with to take your course is on the order of 10, 11, maybe 12, depends on the course. You don't have to learn Mathematica in depth in order to get started in using it. And we're going to give you lots and lots and lots of resources to help you do that. One thing that I will never ever do, I will never ever test you over Mathematica code. This is not a programming class. We use Mathematica as a tool to help you learn mathematics, but I will never test you directly over Mathematica code. I'll test you over the math. Oh, I'll test you. I'll test you over the math, but not over the code itself. So your goal is not to become highly proficient in Mathematica. It's to learn to use the tool to actually access what we are focused on, which is the mathematics. Anyway, if you want, there's tons of resources online for you to go off and learn more Mathematica. But more or less, what you need to know is sitting here in the intro. So this first thing is not an assignment. It's something that I expect you to go through. Oh, there's even a line, you'll never be asked on an exam to produce the code. Never, never. Anybody work their way through this? It's hopefully relatively quick, right? But there are a couple of things that I want to point out to you. One, for example, in plotting a function. So you notice that the format of these lessons is roughly in this way. There is some introduction stuff, there's some code that you can run, and everybody knows by now that this is what an input cell looks like. There are two basic kinds of cells that we use. Input, which can do a calculation, and text. And so as you go through and are working on your homework, you're going to be creating some input cells to run some evaluations, You're also going to be creating some text cells to explain those evaluations. And so you come along and you say, oh, I can put my cursor anywhere inside it, and I can hit Shift Return. And Shift, why do I do the Shift? And why don't I just use a return?
It just makes another line.
Because return is an editing option. I can go in there and I can modify it and put in new lines, right? And so if I want to tell it, I don't want to edit this thing, I want you to send it off and evaluate it. Well, okay, that wasn't that exciting. But you notice that it returned with an output, right? And if I wasn't happy with this function, say that I wanted that to be a 6, I can go in and change it and run it again, and I've changed the function. One of the things about this course, you are in a dynamic environment. A lot of people like to have lots and lots and lots of examples. You are sitting in front of infinitely many examples, as many as you care to engage with. You are not limited by your ability to explore. You can also create your own. You'll notice that if I click between these cell bracket type things, these are called cell brackets. They bracket a particular cell. If I click in between one of these things with a horizontal cursor, I get a horizontal line, and I can start typing. You notice that as a student, any cells that you create are automatically colored green. This makes it very easy for you to tell what was originally there as part of the original text and what stuff that you've added. It also makes it easier for the graders to pick out your contributions for feedback. Clearly that's kind of gibberish or Welsh. I don't know, it could be Welsh. Any Welsh people? No. The point being that the automatic cell creation is a text cell, but if you make a mistake and go, oh my gosh, I didn't want to create a text cell, I want to create an input cell. Again, this is in the how do I, and you work through the documentation. But if I hit the Control key, I can turn it back into an input cell. And in fact, if I wanted, I could, well, let's evaluate that. Okay, it's not very interesting. Here's something that's slightly more interesting. So there's a number. Let me get a little bit more screen real estate. You notice that I can open and close this column if I want to sort of expand things to get more room. Okay, so that's a big number in a text cell. Let's turn it back into an input cell. And say you don't want to actually evaluate that number because it's not very interesting. How about if I put a space between it? What's it going to do if I evaluate it? Any guesses? What's that? Multiply? Yes, it's going to multiply those two numbers. And that's a crazy number. But let's say that I actually wanted to add those two numbers and multiply those numbers. That's a semi-crazy number. But I could also raise that to the 82nd power and raise that to the 93rd power and evaluate again. Oh my goodness. Hey, it did it. Is that correct? No takers. The point being that you are no longer limited by your ability to do hand arithmetic in particular. And in fact, you are no longer limited by your ability to push symbols around. Symbol pushing has a certain importance to it. It's sort of like the multiplication tables or the basic multiplication algorithm. Really useful to know how to multiply two numbers together because it's really hard to get along unless you've got that basic skill. 7 times 8, of course, is 7 times 8 is, there we go. Wow, you guys need to up your processor speed a little bit. So you know what 7 times 8 is, but you'll never ever check that number, right? The point being, as you go through your course, there is a certain emphasis on your ability to do the small types of calculations because those can be used to build your understanding. But then you can put those calculations on steroids and do the really serious problems. Mathematica is a professional tool. It's used throughout industry. It's used on every house on Wall Street. Banks use it. Engineering companies use it. It's used all over as a professional tool. We're not going to use most of the power of Mathematica. Again, 6,000 commands, really powerful. Not going to use most of it, but what we are going to use is its ability to do calculations and present them in a unified environment. All right. As you go through this intro stuff, here's what you must guard against very carefully. Because you can go through here and you can, oh, there's an input cell, I'll shift return, out comes a number, and I'll go on. What you really want to do, because again, you're not going to be asked to produce the code, but you still have to know what the code is doing. And one of the virtues of Mathematica is that's largely self-documenting. You can actually read the code and tell yourself the story of what that code is doing. So for example, here is how you get a table of values of x comma f of x for x ranging from 0 to 10 in increments of looks like 0.5. So if you read the code, it says x jump equals 0.5. Okay. Then I see table of my ordered pairs. I see my variable x, and I see a 1 and a 10 and an x jump. What does that code do? You don't even need to know Mathematica to make a guess, right? First of all, the text above it sort of gave you the hint about what it's going to do. But the point is, you look at the code and read it, not with an idea to be able to reproduce it. You know, if I gave you a blank notebook and say, okay, reproduce it, that's a much harder skill than to be able to look at existing code and see what it's doing. It's going to create a table of values. Oh, and it looks like x starts at 1, ends up here at 10, and changes by step sizes of 0.5. Oh, what if I didn't want it to go up to 10, I just wanted to go up to 6? Well, you look in here and go, I only wanted it to go up to 6. You learn how to modify. By having the code tell you its story, it also tells you the places where you can change the story, right? And so if I'm working on a problem and I want to construct a table of values, I could go off and grab this. If I highlight it and do a copy operation, I can then paste it in. And I can modify it. I could even start at 2, for example. So these are code resources that you can use as you're solving your problem, but you must look at them and try to understand what the code is doing, one, so that you can figure out if it's doing what you want it to do. You're going to have to go back and find code that does what you want it to do. So it's really useful as you go through it to become familiar with what it's doing so that you can then turn around and use it. So I'm not going to go through all this, but there are various things that you can do. Oh, what didn't it like? Maybe I need to go back and run my original code. Table graphics point. Oh, that's interesting. Huh. I don't know. That's a mystery. All right, so don't operate in zombie mode. You have to actually look at what this stuff is doing as you go through it. There are other ways you can get typeset mathematics, right? The nice formulas that you see in textbooks. I wouldn't be so concerned about that, really. I mean, it's nice and makes things look pretty, but it's a substantial amount of effort. But if you want, you can do it. You could do silly things like I could turn that into a typeset math. Okay, that's not that interesting. But if I wanted, I could square it. So you can actually turn things into typeset. This section on troubleshooting is the kinds of ways that you can get in trouble in Mathematica. And there basically are 3 ways you can get in trouble. I'm going to talk about each one of them really quickly. Every built-in command starts with a capital letter. It's case sensitive. So if you type a small p plot, you are not going to get the built-in plot. Everything starts with a capital letter. Functions require an underscore. So here I've cleared some variables and I said f of x equals x squared. And it looks like it did it. And then I come along and say, okay, tell me the value of that at 3. Come on, you can do it. I think my internet connection is a little spotty. Oh, it didn't square it. Why not? Well, it turns out Mathematica did exactly what you asked it to, because Mathematica is really powerful, and you can actually define arguments at the symbol x. You can say, if you've got a symbol x, it doesn't have a value, it's just a symbol, do something with it. I told it what to do if I input x. So what do you think would happen if I create an input cell and ask, what do you know about f of x? Come on. Engage more neurons. What am I going to see? Oh, my internet crapped out. Darn. Oh, there it came. It's really slow. X squared. Because that's what it's supposed to do when I hand it the symbol x. So clearly there's more to defining functions than just putting in a variable name. And so they tell you, hey, an underscore. What the underscore does is say, this is not a variable x. This is a slot, underscore, slot, that you can drop values into. Once you drop it in that slot, it gets replaced on the right-hand side and will evaluate. Catches me, I've been using it 27 years and I still forget the underscore occasionally when I define functions. But the point being, there are a couple places where it will produce stuff that doesn't make a lot of sense. The second thing is that Mathematica surrounds its arguments with square brackets. If you want an f applied to a value x, normally in math notation, you would say f parenthesis x parenthesis. And that's perfectly fine if you're working by hand. But you do realize that that notation that you use by hand is ambiguous. Do you know what ambiguous means? Yes. It means it doesn't have a definite meaning. It could be the symbol f times the symbol x, because you use parentheses to group things, right? Mathematica doesn't try to figure out what you meant to do. It doesn't make a decision about, oh, this is a function applied to an argument versus the product of two symbols. So you have to use square brackets. There's one other thing that you have to be on the lookout for, and it will catch everybody. Say you open up the basics and you say, hey, I would like to learn something about line functions. And so you notice that there's some code, and I can evaluate it. There's a line function. There's another line function, and you can play. And somewhere in here, there's something about dominance on the global scale. Oh, so this is, what is this doing? This is defining, looks like it's defining 3 functions and then plotting them all together. Oh, here's how you can plot more than one function all together. So I'm going to plot this. I'll get to the point in just a second. Oh, and there's 3 functions. Which one is which? Well, you'll notice that there's a plot style red, green, blue. Red corresponds to the first function, green corresponds to the second one, and blue corresponds to the third. It differentiates between them by that color. And you go, oh, drat, I need some coffee. I'm going to save this. Don't forget to save. And I'm going to put this away. It warns you that you're about to put away something. It gives you an opportunity to say, oh, I should have saved it first. But you say yes, and it's gone. And then you go off and get your coffee. And then you come back and say, okay, let me start working again. So I've already got this, and it looks like I've already evaluated that. So I'm just going to continue right where I left off. Right? I'm just going to dive right back in. And I get an empty graph. Why in the world did it do that? Well, it did that because, see, it looks like I should be plotting these functions again. And I didn't get anything. That's because every time you go in and open up a notebook, it knows nothing about the variables in that notebook. It's an entirely new session. So basically what you did, without any preamble, you ask it to plot 3 functions that it does not know anything at all about. How do you cure this? You gotta tell it what those things are. Back up here, you notice this is where they were defined. So if I run that first, and you can tell if something's been run because those little ins and outs appear. If it doesn't have an in appearing next to it, you have not loaded it in. But now that I've loaded in those definitions, and I come down here and plot it over a wider interval, now my graph comes out. This is the one hardest thing to get used to. Mathematica is dumb until you tell it things. You'll run into this, and the very first thing, and this is also a problem if you're going to paste code to the Piazza form. Why doesn't my code work? Why didn't my code give me what I expect? If you were to send this code off to the Piazza forum and say, hey, why didn't this work? There's nothing wrong with this code. What's actually wrong is you didn't evaluate the stuff that needed to be loaded in before you evaluated that, right? So if you're going to post things to Piazza and ask for help, you need more context, right? So you could either load in the previous stuff and give that too, et cetera, right? You got to accommodate that in some fashion. All right. Sounds like a lot of work. Why in the world do I have to mess with all this coding? Come on, anybody thought that? Like, what in the world is all this coding for? Well, you happen to live in the 21st century. 100 years ago, we wouldn't be having this conversation because nobody would have a clue about what a computer was. And in fact, 100 years ago, if you wanted access to calculations, you either did it by hand or you didn't do it. The default position was not to do it at all, by the way. But if you wanted access to it, there were people that were employed as professional calculators. There was actually an industry around just doing calculation. Nobody's going to pay you to do that anymore because we have machines that do it now. This is another thing about why it's important to do this. It's a professional tool. This is something that is going to allow you to work faster, harder, solve bigger problems. The price you're going to pay is that for about 2 weeks, it's going to feel a little unfamiliar to you. I've been doing this for 27 years. It's unfamiliar to everybody at the start. Everybody. Because you've never worked with it before. So of course it's unfamiliar. If you use that as an excuse to go away, you are robbing yourself of an opportunity. But if you engage and keep working through and asking questions, what happens to tech? The tech fades into the woodwork, and you focus on what you're trying to do with the tech, right? You guys have encountered lots of different tech, right? Yes? You guys are the internet generation, of course. You are the internet generation, right? Well, some of us are the internet generation. The point being, it's unfamiliar for a while, but then it fades into the woodwork and you get to concentrate on what you're interested in doing. But that requires you to actively engage. You're not going to be put in a passive mode where you watch video lectures because there are no video lectures. This is being videoed. Seems kind of ironic, doesn't it? This is going to be available as a video. However, the purpose of this video is not to teach you anything. It's to give you an overview. A year from now, I don't expect you to remember anything in this video. A year from now, hopefully, you will have retained something from the course you're about to engage in. Ideally. Anybody taking a math class? Done well in it? A month after the class is over, couldn't talk intelligently about it? Do you see any problem with that? I mean, we're not talking about a decade later. We're talking about literally a month and your brain has flushed it. It's really easy to do. Zombie mode is not just something you can do in an electronic medium, by the way. You can be in zombie mode in an lecture discussion hall. You know what I mean by zombie mode? Yeah, somebody's just up there and they're blathering on and you're mindlessly copying notes. It's really difficult in that medium. It's not that you can't learn in that medium, but it's really difficult to learn in a lecture discussion class because your brain is so engaged in trying to copy that no neurons are actually actively thinking about what does this stuff mean? How are these ideas connected together? It's those connections between ideas that help you to retain things long term. Our brains are not good at memorizing meaningless information. In fact, I've been doing some reading. There are actually mechanisms in the brain that they've started to discover that actively flush stuff out of your brain. Short-term working memory, right? Stuff in short-term memory, you can cram stuff in, spit it out on an exam, and then your brain literally flushes it. Because you got other stuff that you need to bring into short-term memory. If it doesn't make it into long-term memory, you don't have it long-term. The only way to put stuff in long-term memory is to actively engage it, to build the connections, to understand what it means, to see the pictures and relate what goes in and what comes out, to make those connections directly, actively engaged. The reason why we don't have video lectures and have not had them for 27 years, video lectures put you in a passive mode where you are watching but you are not doing. Now, I'm not against video lectures. They're potentially a supplement, but the fact is we've never found a need for them. If you're actively engaged, they don't provide anything additional to you. However, some people may feel, I simply can't learn this way. I really do need lectures. If that's the case, then what I'm trying to do is also help you understand the nature of what you're asked to do. So if you really feel strongly, you can get out early and not be tortured. Because we're not in the torture business, we're in the brain-changing business. However, if you really want to learn this stuff long-term, and especially if you got to take a class that this depends on, or several classes that this depends on, you really benefit from connecting this stuff now so that it will be available later when you need it. Did anybody get the chills? I got the chills. You can actually use this stuff not just a month after the class is over, but years after the class is over. And in fact, I had somebody just the other day email me, a student from 15 years ago, who said that they're still the only ones in their engineering company that understands eigenvalues. All right. Any questions? No, I browbeat you into submission. Well, let's go back to the welcome page. Grading policies. So there are various things connected with this course. Homework is worth 50%. That's a lot. That's a lot. Most math courses don't usually weight homework that heavily. But the primary activity that you're going to be engaged in is interacting with these electronic lessons and working on problems and getting help, et cetera. And so to recognize the great amount of work that's going to be put into it, homework is worth 50%. 2 midterm exams, typically in every course. There might be a couple courses where the number of exams are different, but that's on your particular welcome page. And a final exam worth 25%. Exams are actually worth less than homework in this class. Oh, and there's a 5% communication grade. Really easy to do well on the communication grade. 3% for Piazza participation. Hey, go and participate in the forum. Ask some questions. You can also answer some questions on the forum. And I'm not even going to put a criterion, do I have to make 10 posts to get, because I don't want you to feel like it's a chore to accomplish. It's a resource for you to engage in. Show me that you've engaged in it. I'll give you credit. There's also an end of course survey. That's worth 2%. I'll tell you about how to use the survey as we get closer. That's so that we can continue to get better, right? So your feedback is used to change the way that we try to engage people. All right. Yeah, you'll get more information about it. So your homework, every lesson consists of, like lesson 1, there's a basics and a tutorials. Basics and tutorials are the textbook. But it's an electronic dynamic textbook that you can go in, you can play, you can get lots of examples. Basics is the basic material. Tutorials are applications and extensions of the basic material, right? It's the follow-on stuff. Once you got the basics under your belt, you can move on to the more interesting stuff. Your homework comes from triets. Triets are where your homework is located. So you can think of those as being questions waiting for your answers, whereas the format of basics and tutorials they're in a question and answer format already. Ask a question, answer it. Ask a question, answer it. That's the format of basics and tutorials. So try-its are where ask a question, student provides an answer. There's also, what am I 220? Yeah, 220 has built-in literacies. Not all courses have literacies built in. Some of them are available as PDF downloads. But the question might be asked, okay, I'm doing all this work on a computer, but my exams are paper and pencil. How's that gonna work? Well, it can be challenging to extract what you're doing on a computer to something that you can actually do by hand. So the literacies are the types of questions that you should be able to answer away from the computer. So they are your ways to practice answering questions by hand without computational help. Right, this is meant to be an indicator to help you. And so it's part of your exam prep, but it's also cementing your ability to not use the computer as a crutch, but what your own brain can produce. And so your ability to answer the literacy sheets is directly related to your ability to answer exam type questions. All right. So this one has their literacy handouts. There are also practice exams and solutions so that you have some feeling for what the exams are going to look like, the types of questions you'll see. And those also have solutions that will be provided so that you can sort of test yourself. Ideally, you would try to take the exam, answer the questions, and then look over the solutions. Available as a link. The exam coverage, you know, what lessons are covered on what exam is posted there. Cutoff points for the grades. This is, according to those weights I gave you before, you can actually at any time calculate what your approximate grade is just by using these cutoffs. There are two policies that I want to draw to your attention, one of which might seem frightening to you at first glance. First one is that final grades may or may not be curved at the very end, but nothing individual is going to get curved. And that's an instructor discretion. That would be me. Curves will never, ever be used to your detriment. They're not going to be used against you. If a curve happens, it's because something happened, an exam was like really too hard. I mean, it could happen. Try really hard not to have that happen, but it could happen. So we'll make up for it at the end. Most courses don't need a curve, but it's there if we need it. The second one, no student receives a final grade more than 10% above the exam average. And you go, what? What in the world is that there for? Well, I should give you the good news and the bad news. The good news is less than 1% of students ever fall under that. Less than 1%. Almost nobody ever has that applied to them. Because the exams are constructed very carefully to reflect what you've been doing on the homework, the types of things we've been asking you to do. And so the homework grades and the exam grades are highly correlated for almost all students. If you're getting roughly B's on homework, you can pretty well imagine that you're probably going to end up with B's on the exams, and so you're going to get a B. And that policy doesn't apply to you. However, homework is worth 50%. That's a lot. And so there are, that opens up the possibility that students might try to cut corners on homework. As in, two people decide, hey, let's work together. I'll like construct this week's homework solutions and I'll just give them to you and you can turn them in. We can catch that, by the way. Believe it or not, we can catch that. But the point being, if you don't fully engage with the homework, you tend to not do well in the exams. That correlation works both ways. If you don't do the homework, you don't do well in exams. So this is meant to catch students who try to cut corners. But if you fully intend to engage the homework and ask the questions, et cetera, you can rest assured that this policy will not be applied to you. Any questions? Does that sound okay? I mean, you understand our motivation for instituting that policy? It's not meant to put students at a disadvantage. The only people it catches are the people that we want to catch because they're not fully engaging. You're in the summer term. Summer term moves very fast. There's only 8 weeks, and especially if you're in Calc 220, which is a 5-hour course, that's a lot of work to shoehorn into 8 weeks. So to keep you moving through the material, After the add period, right, while students are still coming into the course, because I don't want to enforce a homework deadline on somebody who just entered, because that seems a little unfriendly to me. But starting with all assignments from 2 weeks from today onward, no late homework is accepted. That's meant to keep you moving through the material, right? Any questions about that? Again, it's to help you pace yourself, right? If you're still trying to turn in lesson 1 and it's the end of the semester, clearly you got a lot of problems. And so our way of helping you move through in a timely fashion. Late homework will not be accepted. And you won't even be able to turn it in. After again, starting from 2 weeks from today, any assignment after that point, I'll go in and I'll turn off hand in. You can still open it up and look at it. You're just not going to be able to hand it in. The due dates for all the lesson try-its are right here. Tells you when they're due, the last date to withdraw, and then the stuff about exams and proctoring. You have 2 options for taking exams. If you're going to be on campus, feel free to sign up for option 1. There are explicit exam dates and locations and times. Tell us and show up at that room and take your exam on campus. If you're not on campus, then you fall under option 2. And because it's remote and you have to schedule exams with a proctor, you have a little bit of flexibility of when to take the exams if you're out going remote. So it's basically it's the previous exam dates plus or minus 2 days. Somewhere in that window, you have to arrange with your proctor to take the exam. You should verify that with your proctor ahead of time to make sure that they are going to be available. However, you don't have as much leeway on the final exam. Final exam, once it's taken, the grades have to be turned in very soon after that for a summer term course. So we can't have as much flexibility because we've got to make sure the exam comes back and gets graded and the final grade determined so I can turn it in on time. Because if I don't turn your final grade in on time, lots of people will get unhappy with me. Not the easiest ones are students. Advisors, deans, registrars, like, where's this grade? I'm like, I don't know, I don't have their final exam. Like to avoid that. So there is information located at summer proctoring. Many of you have already established your proctor. If your proctor can scan in your exam and send it to us, that's the quickest way. Because then we get it like literally at the speed of electrons. If your proctor cannot, then you have to expedite shipping. It's got to get here quickly so that we can grade it and get feedback to you on it. Right? So, yes?
For the final exam, for example, you take 2 classes at once. And
Oh.
6 classes. So how do you do about that?
Well, then you email me.
All right.
Because we've got 13 different courses. So if you can't take it at one time, we can probably schedule you to take it at another time. Yep. Other questions? All right, almost done. Almost all the pain is over. Let the fun begin. Oh, looks like we're done. All right. So no questions at all? Has anybody taken a course? Go ahead.
Will we generally be needing calculators for the exams?
No, calculators are not allowed on the exams. That's a good question. I don't know if I said that. Oh, computers, cell phones, calculators, and written notes are not allowed on any exam. Thought of that one already. That's because the exams are not meant to test how good you are at pushing buttons on a piece of tech. It's about how well do you understand the mathematics, right? And I don't have to ask you a wickedly hard calculational problem to find out, are you connected or not? In fact, it's frighteningly easy to find out if you're connected or not. You want to do an experiment? Let's find out how connected you are. You want to find out how connected you are? I was playing around with something earlier today, and I thought, hey, why not? So you guys have taken algebra before, many of you several times, and you've worked with quadratic functions. Yeah, you factored them, you've expanded them out, you've plotted them. You're like, I'm sick of looking at quadratics. Yeah? One of the cool things about working in dynamic medium is I can start with a generic quadratic, ax squared plus bx plus c, and I can examine what does that look like as I change parameters. This is one of the cool things about working in a dynamic medium versus a static medium like pencil and paper, because you've worked with hundreds of quadratics, right? But have you ever made the connection about what happens to a particular quadratic if I hold everything fixed and just change one of those values? You can explore what's called a parameter space. This has a three-dimensional parameter space, A, B, and C. And there's a different quadratic that comes out for each value of those. There it is. I stuck in some default values. A's got a value of 1, B's got a value of 1, C's got a value of -1. Now here we go. What happens if I change C? What happens to the graph of that function? It's gonna move up and down. Do you know why? Can you articulate why? I'll spot you the answer. So, oh, look at that. Cool. What happens if I change A? A's got a value of 1. What happens if I make A a little bit bigger? What happens to the graph of that? See, this is part of the point. As you work through computationally, you work through these examples and you develop a facility for what do I expect to happen? When I do this calculation, what do I expect to come out? That's important for two reasons. One, if you have an expectation, that means that you've connected, right? You've got an expectation based upon your experience in connection. And oh, by the way, if what comes out is not what you expected, because that can happen, well, then one of two things happened. One, your understanding was flawed, and now you've got an opportunity to learn something, right? Or, oh, I made a mistake somewhere, right? Either way, that's golden. Very few times in life will ever present you right at the moment you make the mistake with the opportunity to go back and correct it or to reinforce your understanding. Now I'm stalling. What happens if I increase A?
It'll get thinner.
It'll get thinner?
Yeah.
Why?
Because there's a larger number being squared, so it'll like go up faster, basically.
The coefficient of x squared, right? Being bigger
Yeah.
means for a particular x value, it should be larger.
Right.
So if you do that all across the function, it looks like it narrows, right? Really what it does is it grows faster. Description, right? Versus, oh, we're connecting. So just to verify, you can even tell that A is positive right from the graph, right? Looking at graphs gives you lots of information about the behavior of functions. So let's just verify, oh yeah. And if I go, oh, close to 0, and then suddenly it goes negative. Cool. Now we're going to find out if you're connected. What happens when I change B? Okay, let's categorize. A kind of controls shape. Doesn't really move the parabola around so much. The vertex doesn't change, but the shape changes. C moves things up and down. What does B do? You worked with all those quadratics. What role does B have in the behavior of that function? Anybody interested? Do you want to know the answer or not? Are you interested? Do you feel in your gut what happens? Well, a lot of people say, well, I've got something that makes it move up and down, that's C. I should have something that makes it move side to side. Does B make things move side to side? And the answer is, sort of. All right, let's do it. Here we go. It does sort of move left, right, but it also moves up, down. And in fact, the vertex of this parabola, the vertex itself moves along a curve. Do you know what that curve is? Let me show you again. Watch the vertex. Oh, let's change A to be something negative. Change the vertex. What curve is it moving along? Would you believe it's moving along another parabola? It moves along a parabola itself. And the answer is, why does it do that? You've seen the derivation of the quadratic formula, right? Somewhere in a math class, they proved the quadratic formula. B occurs at 2 spots in that derivation. X minus b over 2 squared. Remember derivation? Oh, that x minus b over 2 is what makes it move left, right? But then you add a squared term into the constant. Oh, and that's what makes it move up and down, and the whole thing goes along a parabola. The point being, there's a property of something as simple as quadratics that you didn't know about. Easily accessible. Just doing the experiment led us to ask a question. Oh, that's kind of interesting. Why does it move along that curve? What is that curve? Those kinds of questions typically never get asked until somebody plays around and notices something. If you don't have the opportunity to play around and notice, there's a world of mathematics that will be forever hidden from you. Well, if you have no questions, then I'm done. I hope I've helped give you a little bit more understanding about the way the course works. I hope I've given you a little bit of motivation to hang in there and work your way through any problems that you're experiencing. After about 2 weeks, it will smooth out. And then you'll be deriving all the full benefits of being able to work in a dynamic environment.
Are we supposed to get the optional text?
What optional text?
Is there an optional
There is no optional text. If you go to the bookstore, they might have listed for the lecture discussion version optional texts, but there is no optional text for this course. Oh, one other thing. I do encourage you to collaborate with each other. In fact, there's going to be a Piazza post about how you can identify other students in the class and work with them. 2 things about that. I'm very happy if you discuss the material with another person, but your write-ups must be your own. You must do your own work when you turn it in. And that includes pulling things from the internet. Internet's big and bad and got a lot of resources. I encourage you to go off on the internet and learn more about this stuff, read more about it. But don't just copy and paste things from the internet and put it into your homework. That's not your own work.
Is there tutoring or office hours?
I am working right now to set up some office hours at least once a week on campus. It's not a resource I can make available to off-campus students, clearly. But yes, there will be an announcement on Piazza. I'll even try to put it on the welcome page for your course. Yeah, about at least once a week, I'm going to try to get you some on-campus help.
So like the basics and the tutorial, those are basically the interactive lecture?
I would call it an interactive textbook.
Okay.
I mean,
As opposed to like a video lecture?
correct. There are no video lectures, but there is a dynamic environment that you can engage in.
Okay.
All right. Have fun.